Alright guys, hey everyone. This will be lesson 5 and lesson 6 put together. I was able to finish everything and I think I should be able to show what happened or all the problems I went through and everything with this one video. So, if you have any questions at the end, please let me know. So, from lesson 4, we were basically setting a time with the serial monitor. So, we can pull that up real quick. Alright, so everything, you can just go back to the video, but I was just going to show a demonstration. Oops, sorry. Gotta upload it to it. Alright, so now it's uploaded. So you send it to the monitor, and basically we have please set time, and then I have the 8 on the number pad as up, meaning you're going to increase the minutes, and then 1 for end, meaning you're done with the minutes and you're moving on to the hours. So let me see if it works out for me. Yep. So just to show, you can set the hours too. Sorry, that was my fault. So you can set the minutes, then you can set the hours, and then you can start your time. So that was just playing with the serial monitor. We didn't do any hardware or anything. So now lesson 5 was basically doing hardware with the LEDs. So I made it all into one. I'm just gonna scroll down to the function. Always remember to wire your LEDs correctly. Oh, before we even go to this, I wanted to show these 2 little projects that I have on the side. These projects on the side I have, so when I want to move to another project, I can wire it up correctly, and then these projects on the side will show. This will show to make sure that my hardware is wired up correctly. Sorry. So I have the 0 through 5 bit. Then I have the seconds, minutes, hours. Remember, the seconds, minutes, hours are the columns. So once you wire those correctly with the connections that you have, your pins don't have to be the same as mine, but you get the picture. So I have a function saying restart LEDs, meaning I want to turn everything off starting at the top. I want nothing showing. So in order to do that, I have to send all the voltage to ground and all the grounds to voltage. Basically the opposite, to make sure everything is going to 0. So the seconds LED, I just want to show all the LEDs in the seconds just to make sure that all the LEDs are lit up correctly. Wired correctly also. So I have everything high for the bits, but I only have the seconds low, meaning that this is the only one set to ground, meaning those LEDs will get ground. Remember, the LEDs have to have ground for them to light. If you have a high going to a high, that means it won't light. You can go into more details if you want to know a little bit more about diodes. Same thing for minutes and hours. Just make sure that you have the hours low and the minutes low for the function. Calling out a function, I don't know if I explained this. All you have to do is just do an int. What's the name of the function? No spaces in between. Open and close the brackets. If you want to send something to it, I will show later. You just have to put like int something else, whatever variable. So int blah or something like that. And then basically you're grabbing a variable from when you call that function. So I have temp as calling the function. I make sure I comment everything while you're coding, so everybody can be able to go back. So decimal to binary number. Because we're doing a binary clock, we have to turn that decimal number into a binary. I have a test number 10, which is 1010, which is not that bad. It's easy to recognize on a binary, so that's why I chose it. So I have the 0 bit as A and all the way to the 5th bit as F. They don't have to be those. You can name them whatever you like. make sure you set all your LEDs as outputs. Later on, I'll show you what an input would be, which will be later a push button. So I have delay for half a second, restart LEDs. Delay for half a second, show the seconds. Delay for a second, show the minutes, etc., etc. Restart the LEDs. Now down here, I have this little function that I found. Basically, it's taking that 10, dividing it by 1, 2, 4, 8, 16, 32, whatever the bit is, and then seeing what the ending of it after you do the square root of 2. Let me see. If the remaining, right? If there's any remaining after you do square root of 2. Yeah, I think that's correct. So if you do the square root of 2, if there's any remaining, then it will have a number here. If it's not, then it won't light up. So like we want to show 1. So we will do 1 square root of 2, which is a number because the remaining is 1. So when you have a remaining, this is a 1 meaning high, meaning you want to turn it on. Same thing if you want to do 2. So we do 2 divided by 1, square root of 2 is 1. So your B will equal 1. So that means you want to turn on this bit. Same with 4, 8. So if you want to do, let's say 3. So we do 3 divided by 2, you'll have a 1, remaining 1. Oh, 3 divided by 2 is 1, ooh, boy, 3 divided by 2, is 1.5. Yes, wow, having a brain fart here. So you'll have a remaining of 1.5 after you do the square root of 2. So remaining you have 1. Same up here. 3 divided by 1. You'll have a remaining of 1. So that means this bit will have come on. Okay, so going on, just show it. I just want to restart the LEDs, do it for the minutes, and then restart the LEDs and show it for the hours. And I made this function so when I made this project simple, so whenever I have hardware, I want to wire them up, make sure everything's working correctly for my project, run this project, see everything's working properly, then move on. So the buttons, all you have to do is make sure you have it in the middle of the grid, so it'll be easier for you to wire up because you have to use both sides of the push button. Doesn't matter how the rotation is, just make sure you have 2 on one side, 2 on the other side, make sure all 4 are not in the same pin row because they are not going to be wired correct the same. So you have the push button pushed in. So you will want to have voltage going into the top left. So I have the voltage going in the top left, and then I have a resistor going in onto the bottom. Which is going towards the ground. And then I also have the pin where you could get the connection sending back to the board. So technically the push button will be considered as a input. So you're going to take that 5 volts. When you press that button, that 5 volts is going to go to this pin that you have it assigned to. And then the code will know that 5 volts is being sent to that pin. It's really simple. So you can always go to this little sketch, go to examples, and then go to digital, and then go to button. This will come up, and all you will have is an LED and a push button, 1 resistor, and a few wires. It's not that bad. Once you press the button, the LED should light up. If you put the button and the LED on the right pin, as you have here. So I have, for this project, 2 buttons. So I have 13 and 12. So all I did was run 12, press the button, if the LED lights, I'm good to go. That means I wired it correctly. Put it in 13, press the button, if the LED lit up, If the LED lights up, then that'll be great. Then I'll know my buttons are wired correctly. Okay. So the next thing will be going on to the project. So the project I haven't changed anything really. So if you see here, I added 2 buttons. So up button, end button. Same thing that we did on the number pad, the 8 and a 1. So up meaning you're increasing, end button meaning you're done setting the time. I think I added one long. I changed the temps to long, and I added to the push button to grab the voltages. So you have to set that variable to something once you read the voltage. And the decimal to bin number, I have that for the functions that I showed you earlier. The calibration, I want to go into more detail about this. Calibration, you will become a calibrator. Remember, the calibrations are amazing because all you have to do is tweak that one number. It can speed up your project and slow it down, and then you can officially call yourself a calibrator. So I tested a lot of numbers and realized that it had to be between 250 and 300, and found out that 275 was the spot that I felt comfortable with what a second is. So restart LEDs. The functions are the same as we used in our previous. So LED time, I just used that one function that we that one statement with all the A through F that I showed you earlier, and all I did was just put it inside of here. I had the functions saying let me go back to the top. So like I showed you earlier, this one, I want 2 variables to come with this function when I call it. So which one, meaning which column do I want to light up? Do I want to light up the seconds, minutes, hours? So all I did was do, if it's a 1, it's a second, it's a 2, it's a minute, 3, it's the hours, meaning the columns. And then the end LEDs is going to be basically the number that you get from the hours, minutes, and seconds. I don't manipulate the LEDs, the number for the LEDs, so I want to make sure I set it to the decimal 2 bin number, so I don't have to affect anything with that number. So it can just stay in this function and then won't mess with anything else in the code. As you can see, everything stayed the same, so nothing changed. Alright, so once we go into the function, I turned off the serial monitor. The serial monitor was it's good when you're debugging, but once you start doing hardware and you know that your code works, you can turn your serial monitor off. I turned the serial monitor off because it was messing with the wires of the LEDs. So it was basically showing 2 LEDs on and when it wasn't supposed to. So there's a lot going on. So I had to turn that off, realized that after hours that it was a serial monitor, but I'm going to give you that note now. If you're messing with serial monitor and hardware and your hardware is not working properly as you thought, but it was working in your startup, then turn off your serial monitor. It probably will work. Make sure your buttons are set as inputs, your LEDs as outputs. So you call the function, restart LEDs, delay for half a second. I showed the minutes so you know that you're setting the minutes time, because it'll be good for the eye, because remember, this is going to be plugged up to the wall and nobody's going to know which time you're going to be setting. So I have the minutes setting. At the top, I have the hours set to 1, minutes 0, seconds 0, but you can turn the minutes to the midpoint. Oops. So you can do like 15, 30 or something like that if you don't want to start at 0, because I would be upset if I had to make it all the way to 55 and then it would suck. But then it'll suck when you have to go to 0. But you can always input another push button so you can count down and up. That'd be easier. Maybe later on I might do that, because it's kind of hard going all the way. Like right now it's 8:55 and I don't want to increase all the way up to 55 from 0. So maybe you can slip in your Arduino real quick and into your computer and just change the code real quick, and it'll be easier for you if you want to do it that way. But if you want to just have something on your desk a knick-knack or something, you will just have to hold the button and for a very long time. I hate setting my alarm clocks also, so this will be fun. All right, so so the end loops, I have it like basically a step function. Not a step function. I'm sorry. Um, basically, I have it as a case function. Sorry, case statement. So like, I created my own case, so, or steps or whatever you want to call it. So I have it. Once I'm done with this loop, I'll do end loop 1, and I'll move on to the next step. Meaning we're done with step 0, we're moving on to step 1. Some may call it a state machine. So whatever floats your boat. So a delay for a second. Waiting for the push buttons. Reading both the push buttons, the end and the up button. So once the push button up goes high, meaning 5 volts gets there, then you're good. That means you want to increase the minutes. It'll increase your minutes. If it equals 60, it'll go back to 0 for you. And then it will display the LEDs on display the light, the correct LED number. And if you push end anytime, it'll just end this step and break out of that while loop and go ahead and go on to the hours. The hours is exactly the same. Just make sure that you have hours instead of minutes. So everything's same. Your max is 12, or if you want to do 24 hours, you can do that also. As you can see on my display, I have a white LED at the top when you see the startup of my code. So it can show you where the 24 LED would go. So everything is the same for the hours. So once we're done, we're gonna go into here. Calibration. This is where I was tweaking. Because I didn't want to mess with the delays. I just wanted the delay for 1 millisecond. 1 millisecond will keep the LEDs flashing real fast, but the human eye won't see it. So your LEDs will be blinking really fast, but you won't know it. But we want to display it. So I want to turn off, turn on, turn off, turn off. But I don't want them to know that I'm turning off and turning on the LED. So I make sure delay is 1. It's easy to see the difference once you increase the number. So if you wanted to blink hours, turn off, blink minutes, turn off, blink seconds, turn off. If you want to see that, then you just increase these delays. If you don't want to see it, delay 1 is your friend. So it pauses enough for it to be able to show the next LED. Because if you don't have a delay, then it'll be really fast and then you won't see anything. So it'll look like it's off completely. So basically, doing hours, showing the minutes, showing the seconds. I have this temporary index here. It's increasing. That's where the calibration comes in. I just didn't want to mess with delay. So how many times in this loop will it go until it exit and then increase the second? So how long does this while loop go for a whole second? So that's where the calibration came in. So I found out it was like 275 times this loop went around and it equaled a second. So you can do that. That's what simple way I did, because I don't have a clock module, so I had to play with the delays in the code. So once we reach our calibration max, we'll restart the calibration, restart that temporary number, and then increase our seconds. And if our seconds is 59, we'll set it to 0, then increase our minutes. If 59 minutes is reached, then we'll set that to 0 and increase our hours. And then if our hours reach our max, then, oh wow. And if our hours reach our max, then we will set it back to 1, or if you want to do it, if you want to do 24 hours, you will set it to 0. and your max will be 24. So if you want to change that, you'll just have to change these. So these 3 things you'll just have to change. You always can set a code, change this code to max hours, starting hours, and you can have it just change up at the top of the code as a variable. Maybe you can do that. So maybe that will help you out if you want to pass this code to everybody else. But other than that, everything is done. It's really not that bad. You can email me if you have any questions, comments. The code was really simple. It took a long time for me to put everything together, but it wasn't that bad. So, but now you have an Arduino clock, a binary clock on top of that. You are officially a nerd. Congratulations. So my next video will show basically a fast forward video on how I made a closure. I try to go the cheap route to make sure it can still look pretty, and also you don't have to pay that much money. You just have to have a creative mind. So if you have any questions, please let me know. And thanks, guys. See you soon.